them over. If they're on your desk, turn them over. Okay, so today, still talking about exponents because this whole chapter is exponents, okay? Last week, we introduced the rules, right? The 7 rules that we used last week. We're still using those rules. Those rules are still there. I put one extra, it's not really a rule, it's just kind of a hint. If you have the one whole to any power, the number 1, positive 1 to any power, the answer is always going to be 1. That's kind of just like it's not really a rule, it's just kind of it's just like if you take the root of 1, any root, square root, third root, fourth root, fifth root, sixth root, it's always going to be 1. The answer is always going to be 1. It's kind of a little shortcut thing, so you don't have to figure it out. But those rules are still there. So we're not doing any new rules. We're taking one thing into account. Today we're going to see what's called rational exponents. Sometimes they're called fraction exponents. Okay? They have fractions. Sometimes they're positive, sometimes they're negative, right? We saw negative exponents last week. Okay. Okay, so what does it mean if there's a fraction power? What if my power is a fraction and not a whole number? Well, they both mean something. The top is the power. Okay, like you normally would think. Why does it have a bottom? Well, the bottom is the root. Square root, third root, fourth root, fifth root, like we did a couple chapters ago, right? Square root means pairs. Third root means triples. Fourth root means 4 of a kind, that kind of thing. Okay, so sometimes it's going to have a bottom. Okay. So if I have this root, this guy's got a root, right? It's got a 7th root, and the power is 2. So instead of writing it like that, I can give it just a power. So it would be x to the 2 over 7 power. 2 is the power, 7 is the root. Oh, pencil. Okay. 2 is the power, 7 is the root. Okay. Next one. I know the root is 4. That goes on bottom. What's the power? If there is no power, the power is always 1. So both of those are the same guys. These are the same. So if you see 1/4 power, that just means the 4th root. If you see 2/7 power, that means squared and the 7th root. Okay? So let's go the other way. What if they already give you a power? What does it mean? Well, it means it's got a root. It's got a 2nd root, square root, and a 3rd power. Or sorry, square root, 2nd power, 3rd root. So x squared, 3rd root. Okay.
I have a quick question about the wording here.
Yeah.
For this one, it says.
Talk about the directions.
Yeah, I'm just curious. Was that?
That's a typo. It should say this one should say exponential. This one should say radical. Yeah, it was just a typo. I flip-flopped them and I didn't mean to. Yeah, so that means our answer should be an exponent, right? Yep. Exponent. Our answer should be a radical. Yeah. Mm-hmm. Yeah, that's a good catch. You're the only one that caught that. Okay. All right, so this guy. Okay. What power does x get? 1, right? Do we have to write the 1 power? No. So you can if you want, but you don't have to write the 1 power. So what root does it get? 2, square root, right? For square roots, we don't have to write the power either. So this one you're going to see a lot. 1/2. 1/2 means just square root. 1/2 power means take the square root. Okay. Hey, what's up? All right. Believe it or not, this is the new stuff right here. This is the new stuff. Everything we do on the inside, we're going to use these rules. Well, we used them last week. The only difference is sometimes you're going to see fractions. That's it. Sometimes you're going to see fractions. That's all. Okay, so let's look at 3a. So it says simplify, and then they want me to tell what a is going to be. So I'm not really worried about that right now. I'm just looking at this guy right here. We saw this last week. Which rule would we use for this guy? 2. It looks like rule 2, right? Looks like a power to a power. Last week, we multiplied the powers. Guess what we're going to do this week? Same thing. The difference this week is that they're fractions. Okay? So 2/5 times 3/2. Quick refresher. How do we multiply fractions? What's the rules for multiplying fractions? Do we need a common denominator? No. So cross straight across. Yeah, not diagonal, straight across. Straight across. So tops, 2 times 3 makes 6. Bottom, 5 times 2 makes 10. Reduce your fraction, 3/5. So in the question, they said they wanted the power. They wanted a. A is the power. So if this was delta math, I would put a equals my power. That's all they wanted. They just wanted the power. X to the 3/5 is the answer, but they only wanted the power. That's why that a is there. Okay? So multiply. Power to a power. Rule 2 says multiply. Now we don't have any parentheses. So picture those fractions were regular whole numbers. What did we do last week to the powers? Add, subtract, multiply, or divide. We added them, right? Guess what we're going to do today? We're going to add them. It's the same thing. Those rules haven't changed. 3/5 plus 1/6. Okay, when we're adding and subtracting fractions, we need common denominators, right? So what's the common denominator for 5 and 6? 30, right? I think 30 is the smallest number they both go into. So that one I need to multiply times 5. That one I need to multiply times 6. So I get 18 over 30. Oops. Plus 5 over 30. Common denominator is 30. Add. We get 23 over 30. 23 over 30. Can't reduce that. So my power is 23 over 30. Okay. So far we've used the same rules. We're going to use the same rules. There's no like new rules I haven't shown you. All of the rules I showed you. Okay. It's just the only difference today is we might see some fractions. Fraction powers. That's the only difference. This guy, one of them's a fraction, one of them's not. So if we have this, division, right? If we have a division, there's only 2 rules that had division. 5, or actually 3 had division too, but 5 and 7, right? It doesn't have a negative power, so I'm not going to use this 3. Which one am I going to use? Well, this one doesn't have parentheses. Rule 3. Or sorry, rule 5. What do we do with the powers in rule 5? Subtract. So the bottom one doesn't have a power. So if it doesn't have a power, what power does it have? 1. So minus 1 whole. 4/3 minus 1 whole. So 1 whole is 1 over 1. Four thirds. Common denominator is going to be 3, right? So I get x to the 4 thirds minus 3 thirds. Now I can subtract, and I get 1 third. The power is 1 over 3. Okay, that's that part. Mm-hmm.
In this case, like it works kind of if we would just make it into how to say, like, you know how that's an improper fraction. If
Yeah.
we would just like turn it into a whole number. And, like,
Oh, like so 1 and 1/3 you're talking about? Yeah, that worked too.
Okay.
Yeah, that worked too. Yeah. So 4 thirds. Yeah, if the top number is too big for the bottom, you can write it as a what's called a mixed number, 1 and 1/3. Yeah, for sure, you can do that. Yeah, because 4 thirds is the same as 1 and 1/3, right? And then subtract it from a third, you got, or subtract 1 whole, you get 1/3. Yeah, that works too. Yeah, like I said, for adding and subtracting fractions, like you guys learned that a long time ago, and your teacher might have taught you like a method, which you're like, I like that. I then use it. Okay, use it. I'm just doing the textbook. This is what like the textbook way of doing it is. But if your teacher taught you like little tricks to add and subtract fractions, use those by all means, please. Whatever helps you. Okay. Okay, so parentheses. We always start with parentheses. First thing. And then we do negatives. Second thing. And then combine or cancel out, and then reduce if we need to. So those are the same rules we did last week. Okay, so A. So I know this doesn't have any parentheses right now, but I'm going to change it. So instead of a root 36, I'm going to give it a power. So the 36th root is the same thing as 1 over 36. Like a square root is 1/2. Well, the 36th root is 1 over 36. So it gets rid of the root. Okay, so I still have parentheses. So now on the inside of the parentheses, I see I have a negative power. Well, last week we learned that negative powers have to move, either up or down. This one's going to move down. Inside the parentheses, what do I do with the powers on the bottom? Add, subtract, multiply, or divide. Yeah, they're on the same level. Same level, add them. So I get m to the 12th power. Last step, let's finally get rid of the parentheses. Well, to get rid of the parentheses, I have a fraction, so I'm going to have to use rule 7. Give the top a power, give the bottom a power. So the top is going to have a 1/36 power. The bottom is going to have a 1/36 power. One to any power, positive 1 to any power is always going to be just 1. Okay. Now, what do I do with the powers here? Add, subtract, multiply, or divide. Multiply. I got a power to a power. That's multiply. So multiply. Tops, 12 times 1. Positive 12 over 36. Positive 12 over 36. Reduce, I can divide them both by 12. So I get 1/3. Done. Okay. All right, so let's go to the next one. B. Okay, parentheses. Well, inside the parentheses, I see I have two negatives. Since they're on the bottom, they got to move to the top. So s to the fifth times s to the third. What's left on bottom? 1. We don't need to write that one, but it's there. Okay. All right, so now same level. Oops. Add, subtract, multiply, divide the powers. Add the powers. So now I have s to the 8th to the 5/8 power. Multiply. Multiply the powers. S to the s 40, 8 times 5 is 40. 1 times 8 is 8. I can divide those to make 5. Okay. All right. Next one. First thing, just like I did with letter A a couple problems ago, I'm going to get rid of the root. To get rid of the root, what power is the same as a square root? 1/2. Square root and 1/2 power are the same thing. Negatives. Same level. Add the powers. Okay. Give the top a power. Give the bottom a power. Same power. So I got 1 to the 1/2 over c to the 4th to the 1/2. One to any power is just 1. Multiply. I get c to the 4/2. Divide 1/c². Done. Okay. So like I said, I'm just using the same rules that I used last week. There's no extra rules that I'm using. The only difference is you're going to have some powers that are fractions. That's the only difference. So you can still add fractions. You can still subtract fractions. You can still multiply fractions. Just treat them as real regular numbers. Okay? All right, here we go. All right, letter D. Letter D, we changed it up a little bit. Letter D, they want me to take that guy and change it to a radical and reduce it as far as you can. So my first step is to change it into a radical. What power is 24 going to get? 1, right? The top is the power. So it's going to be 24 to the 1 power, which just means 24. The bottom is the root. Square root, right? Square root. You can write the 2. You don't have to if you don't want to. So really, this is just the square root of 24, right? That's the first step. Second step, look for pairs. It's a square root. Look for pairs. That's how you simplify the root. So 24 is 6 times 4. 3 times 2, circle, circle. 4 is 2 times 2. So 24 is 3 times 2 times 2 times 2. It's got a pair. It's got one pair. So a 2 could come out. 3 times 2 is 6. Those guys don't have any pairs, so they got to stay. 3 and 2 don't have any pairs, so they got to stay. Done. That's what we did a couple chapters ago. Okay. All right, so we got one more in the notes, and then I'm going to give you a couple more since we got some extra time. I'm going to give you a couple more, and then we'll be done for today. Okay? Just a couple more practice after that. Question? Yes, yes, sir.
24 there. It's 2 to the power of 1, right?
Yes. So anything to the power of 1 is itself. So that's why I just wrote it without a power. Yeah. So if it was 24 squared, we're going to see this on the next one. I'd have to write 24 times 24. Yeah. We're going to see this on the next one. Yeah. I think I'm going to answer your question on the next one. Okay. So this guy right here. Change this to a radical and then simplify it. Okay. So we got 27. What power is 27? 5 power. And it's the third root, right? Third root means triples.
Yeah.
Okay. So this is what I have. 25 times 20, oh, not 25. 27 times 27 times 27 times 27 times 27, right? That's what I have. So I have 5 27s. I'm not going to break down all of them. They're the same number. I'm going to break down one of them. So let me see, 27. If I break down 27, I get 9 times 3. Circle the 3. 3 times 3. So each one of those 27s, has 3 3s. Each one of those 27s is 3 times 3 times 3. So use your mental math. How many 3s do I have total? 15, right? 15. This guy has 3. 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 Put them all together, you have 15 3s. So yeah, so it's going to be root 3
3 to the 15th power.
3 to the 15th power, because each one of them had three threes, right? So I have 15 threes. 3 times 3 times 3 times 3 times 3 times 3 times 3, 15 times. How many groups of 3 am I going to have? 5.
So it's going to be 3 to the 5th.
Do I have anything left underneath? There's nothing left over, right?
So 3 to the 5th is the same thing as 243. That's your answer.
No more root. Didn't need the root anymore. There was nothing left on the inside. Because I was looking for groups of 3 and I had 15. 5 groups. Okay. All right. Okay, so on page 34, I'm going to give you 2 more to do on your own practice, and then we'll be done. Okay? So I'm going to give you, I'll pass out the tape right now so you can tape it in. Letter C. So the first guy changed the power. Instead of root 12, change it to 112. Then you move the negative down. When I move the negative down, I can combine to make 9. Okay? Top gets a power, bottom gets a power. So the top is just going to be 1. The bottom, when you multiply, it's going to be 9 over 12. You can reduce 9 over 12 to 1/3. No, 1/4, right? No. 3/4, right? Yeah, it's 3/4. Yeah. 3/4. Sorry. 3/4. Yep. Done? Next one, we'll change it, give it a power. No roots. So this is 1 over 4, and this is 7 and over 5/6. Well, from there, it's just rule number 1. Add the powers. Common denominator is going to be 12. So I get 3/12 plus 10/12 equals 13/12. Done. Okay. So like I said, it's just the same rules. The only difference is you might have a fraction here and there. You can still add fractions. You can still multiply fractions, subtract fractions. That's it. Okay. All right. So make sure those are taped in.